Hello and welcome to this video in the measurement series, this time with surface area and volume of composite solids. So composite solids being those types of solids that are not the same as right prisms or pyramids or even spheres. These are the types of things that have multiple solids, three-dimensional shapes put together to create a new three-dimensional shape. So it could be some rectangles together with some triangles. There could even be some holes put in them by squares or circles and things like that. So that's composite solids. So it's made up of a composite of different things. Let's start with some surface area. And all we need to really do is we need to visualize those surfaces of the solid, and that is something that is common when you're talking about surface area in general, is that you want to visualize all the different surfaces that we are working on. Find the area of each one and work on it that way. Now here's our example here. Here's our example. We have a red cube. It's a red cube structure that's in New York, and it has a cube with a cylindrical hole removed from the center. The side length of that cube is 8.53 meters, and the radius of the cylindrical hole is 1.42 meters. So the important pieces here: side length of the cube and radius of the cylinder. Okay, because the height of that cylinder is still going to be the side of the square. So we're going to find the surface area, or we're going to find parts of the surface area. So we want the face of the cube that has the hole in it. Okay, so that's this first one. And because it's got the cylindrical hole, we want it corrected 2 decimal places, simply because we're going to be dealing with pi. So area of that face is going to be the area of that square, which is s squared. And we're going to take away the area of the circle being pi r squared. Pi r squared. So that's how we're going to set this up. We substitute in what we know for the pronumerals in here. So we know the side of the square is 8.53 meters. Square that. We go pi times r, which is the radius of the circle, which is 1.42 meters squared. I like to put things in brackets sometimes just to see if we can keep things a little bit under control as to how they need to get done. Just makes things a little bit nicer to do. We pop that into a calculator and we're going to get 66.4261 on and on and on. Now we're rounding to 2 decimal places. So I find that second decimal place just like that. Look at the third decimal place number. This one falls in the 5 or above category. So our 2 in our second decimal place will need to become a 3. And as we have done in previous videos, this is now an approximation. So we want our squiggly equals sign, which is our approximately equals sign, and then 4, 3. Now the only thing missing now from my answer here is meters squared. So the units squared. So it's squared this time because we are using area, not volume. So this one's just area. Next question is, what is the surface area of the whole red cube? So we only want the outer red surfaces. So it's not the center bit where the cylinder is. We just want that outside shape. So surface area is going to be 2 lots of the one that we just found. So there are 2 sides of this cube that have the hole in it. So we're going to have 2 lots of 66.43. So we're actually going to keep that particular part of it in. And then we're going to add it to 4 lots because there are now 4 sides left over. As you do, imagine there are 6 sides to a cube. 2 of those sides have been taken care of. We have 4 sides left over. And one of those regular sides is just 8.53 squared. And there we have what we need. Now we can start this with a formula if you really wanted to, but it could get a little bit cumbersome, and this one's a little bit more straightforward. Chuck that in our calculator. And this is what we're going to get. Now, again, we want to round off because we have done a few little extra bits and pieces. We want 2 decimal places yet again. So 2 decimal places yet again, and you can see here we're going to get a little bit confused. So looking at that number, this one is in the 5 or above category yet again. However, this time we have a 9 in front. So that 9 becomes a 10. So because we can't have 2 digits in each decimal place, that 9 goes up to 0 because we're going to add that extra 1 to the 8. We're going to add the extra 1 to the 8, and again, it's an approximation, so 423. So we've added the 1 to the 8, so now we have 90, and again, meters squared. So that's looking at some surface area of composite solids. We've done one thing to get another, and now we're going to do that with volume. Okay, so now we're moving on to the volume of composite solids, So we've still got our 3-dimensional shapes plugged together to make a different 3-dimensional shape. And we're going to use those different types of volume formulas that we've used previously. So this is about figuring out which is what and applying the correct formula. So here's our example. We have some grain silos. And our grain silos are made up of a cylinder and a cone put on the top. So the first thing we need to have a look at in our question is what's going on. So we've got our grain silos. The diameter of the cylinder part of the silo is 16 meters. Now that's all well and good, but we actually need the radius. We need the radius of that silo. So if I was to take the radius of the silo, that's 16 divided by 2, which is 8 meters. So that's going to become very important. We're going to use that a couple of times. The height of that cylinder is 20 meters. Okay, the diameter of the base of the cone is the same as the cylinder, so we're going to have to use that 8 meters again. And the height of the cone, this time, is 2 meters. So we've got 2 different heights to work with. Alright, and we want the volume of the solid or the silo to 1 decimal place. Now we do have 2 shapes here to work with. We have the cylinder and we have the cone. So the volume is going to be the cylinder plus the cone. So for the cylinder, we're just having AH, and the cone is a third AH. Okay, so that's how they're working together. We have the cylinder is AH and the cone is a third AH. Let's break that down even further to the individual bits and pieces that go into those shapes. So the area for the cylinder, the area of that face for the cylinder is a circle. Therefore, we're going to use that circle area, pi r squared, and then the h. And then we're going to have the area again of that circle, pi r squared, and then another h. So it's only a third of it this time. Okay, so we're almost up to the point where we're going to substitute. Well, we are up to the point to substituting. So just to keep things a little bit easier, we're going to have pi times 8 squared times 20 for the cylinder. Then we're going to add that to another bracket. We're going to have a third times pi times 8 squared again, times the height of the cylinder, which is 2. Okay, so the cylinder is 20, the cone, is 2. So we've got our two different heights going. We plug that into a calculator. We get 4,155.2798883. But we only want one decimal place. That's the important part there. So here we go. Let's go to that first decimal place. I'm going to put that line behind it and look at that next number. That next number is a 7. 7 is in the 5 or above category, which means that the 2 is going to have to go up to a 3. I'm going to use my approximately equals sign because it is an approximation. 4155 doesn't change there. That 2 becomes a 3. And then we have meters cubed. Okay, so that is how we are looking at the surface area and the volume of composite shapes, composite solids, where you have multiple 3D shapes popped together to create one different shape or one different solid. Hopefully that has helped you with those problems, and we'll catch you in the next video.